Welcome to the lecture on order of operations. We're going to review PEMDAS, which is a saying to help you remember the 6 different things you need to check for when doing order of operations. P stands for parentheses. It's actually a little bit more general than that. It can stand for any kind of grouping symbol at all, like parentheses, or you could see curly braces or brackets, or even a big fraction bar where you think of the stuff on top and the stuff in bottom as being surrounded by parentheses. So any kind of grouping symbol counts as parentheses P. E stands for exponents, and then M and D stand for multiplication and division. There isn't really any priority to multiplication versus division. What you need to make sure of is that you do whichever operation comes first in order from left to right. The same holds true for addition and subtraction. So whichever operation, addition or subtraction, comes first, you want to do in order from left to right. So if we take a look at our first example, this one has a very large fraction, and remember when I just mentioned large fraction bar as sort of a grouping symbol, you want to kind of think of there being implied parentheses around the entire numerator and implied parentheses around the entire denominator. So we're going to do everything in the top, simplify the top to a single number. Then we're going to do everything in the bottom, simplify the bottom to a single number. And the very last thing we will do is the actual division of that fraction bar. So let's start on the top. Within the top, we've got brackets, which is another kind of grouping symbol. We've got some exponents, we've got division, and we've got some multiplication and some subtraction. So we've got a little bit of everything. Where do we start? We need to start in the brackets. That's our first set of parentheses. Within the parentheses, we've got an exponent. So we're going to start with that 2 squared. 2 squared becomes 4. And I'm just going to recopy everything else temporarily because I haven't used it yet. So all I did there was the square. Now within those brackets, I have division and I have subtraction. Division ranks higher than subtraction. So I'm going to do this division first. 4 divided by 2 is 2. So then I'm going to recopy every other number that I haven't used yet. I'm still not done with my brackets yet. I need to do the subtraction. 2 minus 1 becomes 1. And that 1 is a single number, still into my brackets here, recopying everything else. And now I have what's in the parentheses or in those brackets down to a single number, so I'm ready to look at the rest of what's in the numerator. In the numerator, I have an exponent, subtraction, and between the 5 and the 1, there's implied multiplication. So out of all those things, exponents rank highest. 3 cubed means 3 times 3 times 3, which is 27. And then when I get down to the subtraction and the multiplication, multiplication comes next. 5 times 1 is 5. And finally, the last thing that I get to do here is the subtraction on top. 27 minus 5 is 22. So the number on top reduces down to 22. Now we need to go back to the denominator. We haven't done any of that yet. So in the denominator we have addition and we have multiplication. I'm going to do the multiplication first because it ranks higher. 6 times 3 is 18. And now I can add in that 4. 4 plus 18 is 22. So these denominators are going to be 22 all the way throughout the problem. So down to the very end, I had 22 on top, 22 on bottom. This is a fraction, and anytime you are giving a fraction as an answer, you want to make sure it's reduced. 22 divided by 22 reduces to 1. So my final answer is 1. Okay, let's try another one. Now this next example is meant to purposely trick you. When you look at this problem, there's lots of division, there's lots of multiplication, and over here on the end there's even some parentheses. That's where I need to start first because there's stuff inside of those parentheses that needs to be reduced first. negative 2 minus 2 is negative 4. So I'm going to put in my negative 4, I'm going to leave it wrapped in parentheses, and I'm just going to recopy all these other numbers that I haven't even touched yet, so that I make sure that I don't lose anything. So all I did in that step was reduce the parentheses. In my next step, here is where a lot of students get into trouble. The way this problem is written, it's really very common for students to look at this and want to immediately multiply negative 3 times 2 or negative 1 times negative 4. Unfortunately, that's going to give you the wrong answer, because according to order of operations, we've got division right here, and we have multiplication between the negative 3 and the 2, another division, and another multiplication. And we're supposed to do those divides and those multiplies in order from left to right. So even though we kind of want to do the negative 3 times 2, we actually have to do this very first division first. Negative 24 divided by negative 3 becomes a positive 8. Now I haven't used this 2 yet, so I'm going to bring that down. I haven't done this divide, I haven't done my negative 1, and I haven't done my negative 4. So those are all still left. So I have a multiplication, a division, and another multiplication. Going left to right again, this multiplication needs to come next. 8 times 2 is 16. I'm going to recopy what's left over here. And again, it's really tempting to want to multiply negative 1 times negative 4, but this division comes first left to right. So I have to do 16 divided by negative 1, which is negative 16 first. Then, the very last thing I get to do is the multiplication by that negative 4. So negative 16 times negative 4 becomes positive 64. So always go in order from left to right when you see multiplications and divisions or additions and subtractions. Let's try a next example. This one has absolute value bars. That's what these vertical bars are. They act just like another grouping symbol, like parentheses or brackets or a fraction bar. So when we look at this problem, this is where we need to start first. And within there we have a subtraction, and then we have this implied multiplication between 3 and negative 2. So that's where we need to start. Multiplication ranks higher. Now I like to think of this 3 as actually a negative 3. So a negative 3 times a negative 2 becomes a positive 6. And that negative 15 is still there. So we have two negatives, they turn into a positive. And now we're left with, I'm just going to recopy the rest of the problem so I don't forget about it. Now we're left with negative 15 plus 6, which I can figure out to be negative 9. That's still inside my absolute values, and I'm just recopying as I go. And now finally I have a single number inside my absolute value, so I'm ready to actually apply the absolute value. Remember, absolute value just makes your number positive. So absolute value of negative 9 becomes positive 9. Absolute value of negative 5 becomes positive 5. But this subtraction in between is still there. Be careful here. This negative and this negative do not cancel each other out. You need to evaluate this grouping symbol first before you do the subtraction. So 9 minus 5 gives me a final answer of 4. Next example, another big fraction with absolute value bars in it, which are acting like a grouping symbol. So in this problem, I need to start here first, and I'm going to do the top separately from the bottom. So I'm going to recopy my 8 and my negative 1 and my subtraction. I'm not going to do those yet. I'm going to do negative 4 times negative 3, which is positive 12, and that's still in my absolute value bars. Let's finish the top before we look at the bottom. Within this numerator now, I've got still more grouping symbol here. I need to finish off this absolute value first. So absolute value of 12 stays 12. However, there's still subtraction in front of it. So we just got rid of the absolute value bars there. Now in the numerator, I've got the multiplication between 8 and negative 1 and subtraction. So we want to do our multiplication next. 8 times negative 1 is negative 8. And finally, I get to do my subtraction. Negative 8 minus 12, they're both negative, so we're actually adding. 8 and 12 make 20, but the answer stays negative. So the numerator of the original problem became negative 20. Now let's do the denominator. Negative 6 minus negative 1. We have a double negative there. So remember, a double negative becomes plus plus. So this is actually negative 6 plus a 1. And negative 6 plus 1 is negative 5. So the denominator reduces to a negative 5. To get your final answer, you're actually going to do the division last. Negative 20 divided by negative 5 becomes positive 4. Okay, on our next example, we have a lot of stuff going on. We have parentheses here, and then this big fraction, remember, acts like it has implied parentheses around the numerator and around the denominator. So I actually have 3 sets of parentheses, and I'm going to do them all sort of simultaneously. 2 minus 6 is negative 4. I'll leave that in parentheses for now. Then I have my division, and then for my big fraction, in the numerator, negative 2 minus 6 is negative 8. In the denominator, negative 3 minus 6 is negative 9. And then I have this subtraction by a half off to the side. Now, on this problem, the next thing that I probably would do would be to reduce this fraction as much as I could. Now, 8/9 is reduced, but the negatives could be canceled out. A double negative becomes a positive. So this is actually a negative 4 divided by positive 8/9 minus that 1/2. Now we have division and subtraction. Division ranks first. When you're dividing by a fraction, remember that is the same as multiplying by a reciprocal, but you're multiplying by the reciprocal of the second fraction only. So I'm actually going to leave negative 4 the way it is, change this division to a multiplication, and 8/9 gets flipped over to its reciprocal, 9/8. Now to do this actual multiplication, I like to think of it as a fraction times a fraction, so I put that negative 4 over 1. And when you're doing fractions and multiplying them, a times b over c times d, it's going to be ab over cd, or top times top over bottom times bottom. So on this problem, negative 4 times 9 would be negative 36. 1 times 8 would be 8. Now, is that reduced? No. Both 36 and 9 are divisible by 4, so let's reduce that fraction. Negative 36 divided by 4 is going to be negative 9, and 8 divided by 4 is 2. So there's my reduced fraction, and that actually puts us in good shape, because what we're left with here is now a subtraction problem. And when you're subtracting or adding fractions, it's actually can be a little bit of trouble if you don't have a common denominator, but in this problem we do. We get a little lucky. So here we don't have to worry about common denominators. Negative 9/2 minus 1/2 is going to be negative 10/2. Is that reduced? No. So make sure you divide. Negative 10 divided by 2 becomes negative 5. So the final answer is a negative 5. Okay, our last example here is actually initially a substitution problem. We're given this fraction with variables m and n, and what we want to do is simplify it when m is negative 3 and n is negative 2. So we're going to substitute in first. Now when you substitute any values in, you always want to make sure to wrap the numbers that you're substituting in parentheses. So when substituting, always use parentheses. It will help cut down on the amount of mistakes that you make. So what I mean by that is, in this example, any place where I see an m, I'm going to substitute in negative 3 wrapped in parentheses. Any place I put in n's value, I'm going to wrap it in parentheses first. So the actual substitution step will give me this. Negative from up here, then parentheses the value of m, which was -3, close the parentheses, then the value of n, which was -2, close the parentheses and put the square on the outside of the parentheses, minus m, wrapped in parentheses again. And then in the denominator, we have n's value, which was -2 in parentheses, minus m's value, which was -3. So here's our new order of operations problem. Again, it's a big fraction, so we're going to do the numerator first, then the denominator, and then simplify. Now in the numerator, we have an exponent, so I'm going to do this first, and this is an easy place to make a mistake. When you are squaring -2, you're squaring not only the 2, but you're also squaring the negative. So -2 times -2 becomes a +4. If you're using your calculator, you want to make sure you type in parentheses -2 squared on your calculator, otherwise you'll get the wrong answer. So this becomes +4. Let me recopy the rest of the problem temporarily. Now going back to the top here, what's next is going to be the multiplication that's between the 3 and the 4. And this is actually a -3 times 4. Well, we know that 3 times 4 is 12. And how do you determine the sign? Count the negatives. If there's an even number of negatives, your answer is positive. If there's an odd number of negatives, your answer is negative. We have 2 minus signs, 2 negatives. That's an even number, so my answer is going to be +12. So all of this becomes +12. Then we have our minus, -3. And there's that double negative again. So a minus minus becomes plus. So this is really 12 plus 3 on top, which is going to simplify to 15. So the numerator is 15. Now to the denominator. In the denominator we have -2 minus -3. There's that double negative again, so these become pluses. So this is really -2 plus a 3. And I'm dropping the parentheses here because I don't have any multiplications to do in front. So I don't really need to have the parentheses in the denominator anymore. -2 plus 3 is +1. So the denominator is 1. So we have 15 over 1, and that reduces to 15. So that finishes our lecture on order of operations. Just remember PEMDAS. Good luck.